So the testes have inside of them seminiferous tubules, and this is where spermatogenesis occurs. So this is the production of sperm. So we have a diploid cell called a spermatogonia. So this cell is diploid, or these cells are diploid. And they are actually going to undergo mitosis to produce two diploid cells, and one of those diploid cells is going to continue on to become the sperm. So I'm just going to just talk about that, and I'll show you the image that you have in your book. So the spermatogonia are going to go through two stages of meiosis. So meiosis 1 and meiosis 2, right? And so ultimately, we are going to have 4 haploid cells. So these are going to be the sperm. These are small cells, and in the case of our sperm, human sperm, they have lost most of their cytoplasm. So if we look at the structure of the sperm, we have the head, and then we have this midpiece that has these specialized mitochondria, spiral mitochondria, and then a cytoskeleton element called the flagella. So this is the nucleus of the sperm. This is the head region. This is my midpiece region. And this would be the tail. So this is the flagellum. So in humans, we have in our diploid cells 23 pairs of chromosomes. So we have 46 total. You get half of your chromosomes from your mother and half of your chromosomes from your father. In the haploid cells, we have 23 total chromosomes. So in that case, it has to be the sperm and the egg that come together to produce a diploid fertilized egg that could then become a zygote, and that could then undergo embryonic development to produce a whole new individual that is genetically different from the parents. And so in your book, you have a diagram of this. That's not what it looks like in your book, but this just shows a cross section through the seminiferous tubules. This is so interesting, the way that this works. Your sperm start off, and as meiosis proceeds, they move towards the center. And so at the very center, you could see the sperm with the head and the midpiece and the flagellum. They're all kind of facing out, right? With the tail actually in, with the tails out. When we look at the ways that these develop, there's these gigantic cells. You don't need to know this, but they're called Sertoli cells. And spermatogenesis actually occurs inside of another cell. And that helps to protect the sperm from the immune system, so that the immune system doesn't damage the developing sperm. Then you can see here that these two seminiferous tubules are connected eventually to the epididymis, which then eventually is connected to the ductus deferens, or the vas deferens. So this diagram shows the Spermatagonium undergoing mitosis, so that there's two, so that during a male's lifetime, he never runs out of sperm. They are always continually produced. We have meiosis occurring 1 and 2, and then we get the development of the sperm. They actually shed their excess cytoplasm so that they can become very fast and mobile, and actually compete for access to the egg.